Hi everyone, so welcome back to my channel Mathematic Girls Swati 3226. In this particular video, I'm going to cover some important questions and some basic questions I can say of the topic trigonometric function. Of course, this topic is from class 11. So all the 11th graders, if you are watching this video, make sure you watch this video till the end because I'm going to cover the basics, like of the trigonometric function. All the basic questions I'm going to take in this particular video. So let's start with the first one. We are going to first calculate the value of some certain trigonometric angles, which are actually not directly given, in the formula. For example, we know that sine 45 is 1 upon root. We know that sine 60 is root 3 by 2. But we have certain angles like sine 15, cos 75, these angles. So for that, we need to find out the values by using some formula. So this is what I'm going to do. So the very first angle that we have to find is sine 15 degree. Okay. Of course, we don't have the direct value for sine 15 degree. So how we can start this? We will simply write down sine as it is. And we can write down this 15 degree as 45 minus 30. Of course, 45 minus 30 is 15. Now here I'm going to use a formula, and the formula is of sine A minus B. So the formula of sine A minus B is sine A cos B minus cos A sine. So using this formula, this will become sine A, that is 45, cos B, that is 30, of course, minus cos A. So A is 45. See, this is A and this is B. So cos 45 and then sine 30. Okay, using the formula. Now the value of sine 45. If you know already, it's very good. But if you don't know, you can just have a look at it on the formula sheet. That what is the value of sine 45? It is fixed. It is 1 upon root. The value of cos 30 is root 3 over 2 minus, this is cos 45. The value of cos 45 is also 1 upon root 2. And the value of sine 30 is 1 by 2. Okay. So I'm not writing these values on the other side because these are the directly given formula, given values. So I'm directly going to use them. Okay. Of course, this will become numerator with numerator. So 1 into root 3 will be root 3 upon, this is 2 into root 2, that is 2 root 2 minus 1 into 1 is 1 and upon 2 root 2. Now we can leave the answer here, or if you want, you can just simply take the LCM and this will become 2 root 2. And in the numerator, we will have root 3 minus 1. And this is the answer. All right, now we can go to the next one. So we have, basically 6 angles that we will be finding out here. So next is cos 15 degree. Okay. Again, it's very simple. We can write down the same way. Cos 15 degree, we can write down as 45 minus 30. But here the formula is little different. What is the formula of cos A minus B? Let us see that. So the formula of cos A minus B is cos A cos B plus sine A sine B. So using this formula, we will get cos A, that is cos 45, cos B, that is cos 30, plus sine A sine B, that is sine 45, sine 30. Now, what is this cos 45? This cos 45 is 1 upon root 2. What is this cos 30? The value of cos 30, we already know it is root 3 by 2. Plus sine 45, 1 upon root 2. And sine 30 is, of course, 1 by 2. Right? So all these the values that I'm going to use, that I'm using here, you make sure you have that sheet with you. And if you remember the formulas, the values, very good. So this will become, if I take here the LCM, before taking the LCM, I can just solve this, simplify this further. So 1 into root 3 is root 3 upon root 2 into 2 is 2 root 2. Plus 1 upon, this is 2 into root 2 is 2 root 2. If I take LCM, this will become root 3 plus 1 upon 2 root 2. And that's the answer. Okay, now we can go to the next one. That is the third question. That is tan 15 degree. So we are basically going to find out the 75 and 15, 15 degree and 75 degree for all the trigonometric functions. Okay, for sine, cos, and tan. Okay, not the cosec, cot, and cot. So tan 15 degree, of course, we can start this way. Tan 15 degree, we can write down as again 45 minus 30 only. And now we have to use the formula of tan A minus B. Now, what is the formula of tan A minus B? The formula of tan A minus B is tan A minus tan B upon 1 plus tan A tan B. Right? So tan A into tan B. So using this formula, it will become tan A, that is tan 45, minus tan B, that is tan 30, upon 1 plus tan A, that is tan 45, into tan B, that is just tan 30. Right? If there is no sign between tan 45 and tan 30, it is a multiplication sign. Okay, now, of course, just like we had the values for sine and cos, we have the values for tan as well. So the value of tan 45 is 1 minus the value of tan 30 is 1 upon root 3. Upon, this is 1 plus tan 45 is 1 and tan 30 is 1 upon root 3. If you simplify this, it is 1 minus 1 upon root 3. Upon, this will become 1 plus 1 into 1 is 1 upon root 3. I'll take the LCM in the numerator. So this will become root 3 minus 1 upon root 3. And this will become root 3 plus 1 upon root 3. Of course, this root 3 will get cancelled. So what is the final answer we are getting? The final answer that we are getting here is root 3 minus 1 upon root 3 plus 1. So root 3 minus 1 upon root 3 plus 1. And that's the answer. All right, we are done with the third one. Let's move to the fourth one. So now we will change the value from 15 to 75. So we will find out the value of sine 75 degree. How can we write down sine 75 degree? So we will first write down 75 as 45 plus 30. Of course, it's very clear. We can write down 75 as 45 plus 30. Now, again, here we are going to use the formula, but it is now sine A plus B. So I'll be writing the formulas as well. Remember, it's very, very important, and I can say it's quite mandatory to use the to write down the formulas that you are using in your questions. Okay, so this is sine A plus B. Of course, it is in this form, and the formula is sine A cos B plus cos A sine B. So using this formula, it will become sine 45 and then cos B, that is cos 30, plus cos A, that is cos 45, and sine B, that is sine 30. Now the value of sine 45, 1 upon root 2, the value of cos 30, root 3 by 2, plus the value of cos 45, 1 upon root 2, and the value of sine 30 is 1 by 2. So this will become root 3 upon 2 into root 2 is 2 root 2, plus 1 into 1 is 1 upon 2 into root 2 is 2 root 2. Now here if I take LCM, it will become 2 root 2, and in the numerator we have only root 3 plus 1, and that's the answer. So these are the values, okay? So if you have any question where sine 75 is included, make sure you derive the formula then and there only. Okay, you don't have to remember that, okay, sine 75, the value is root 3 plus 1 upon 2 root 2. Okay, so every time you can just derive your own value. Okay, now we can go to the fifth one, that is E, and that is cos 75. Okay, so for cos 75, of course we can write down cos 75 as cos again 45 plus 30. Now this is in the form of cos A plus B. We know the formula of cos A plus B. Cos A plus B, the formula is cos A cos B minus sin A sin B. Using this formula, it will become cos 45 cos 30 minus sin 45 sin 30. Now, the value of cos 45, 1 upon root 2. The value of cos 30, it is root 3 by 2, right? Minus sin 45, 1 upon root 2, and the value of sin 30 is 1 upon 2. Now, this will become root 3, and then this is 2 into root 2, that is 2 root 2, minus 1 into 1 is 1, 2 into root 2 is 2 root 2. If I take LCM here, it is 2 root 2 in the denominator, and in the numerator, root 3 minus 1, and that is the answer. Now let's do our last question of this, find the value of. After that also we have few more questions. So let's do our last question of this, tan 75 degree. So how can we find out the value of tan 75 degree? Very simple. We can write down 75 again as 45 plus 30. And now here we have the formula of tan A plus B. So the formula of tan A plus B is tan A plus tan B upon 1 minus tan A tan B. Now using this formula, it will become tan 45 plus tan 30 upon tan 1 minus tan A, that is tan 45, tan B, that is tan 30, right? Now what is this tan 45? The value of tan 45 we all know is 1. The value of tan 30 is 1 upon root 3 upon 1 minus the value of tan 45 is 1 and the value of tan 30 is 1 upon root 3. Now if I simplify the numerator by taking LCM, it will become root 3 plus 1 upon root 3. In the denominator, let's just write on one more step. 1 minus 1 into 1 is 1 and then upon root 3. Now this will become root 3 plus 1 upon root 3. And in the denominator, if I take the LCM, it will become root 3 minus 1 upon root 3. Now this root 3 will get cancelled. So we are getting root 3 plus 1 upon root 3 minus 1. And that's the answer. So we are done with these 6 questions where we just found out the values of, sine, cos and tan of 15 degree and sine, cos and tan of 75 degree. Now let's move to the next question. So in the next question, we have to prove. So we have to basically prove that sine 105 degree plus cos 105 degree, that will be 1 upon root 2. This is what we need to prove. Of course, by looking at the question, you can say that we don't know the value of 105 degree, right? Because we don't have. So what we will do, we will again use some formulas here. So for that, I'll just write down whatever we have on the LHS, that is left-hand side. So on the left-hand side, we have sine 105 degree plus cos 105 degree, right? Now, sine, I can write down this 105 degree as 60 plus 45. Of course, we can write down. Plus, I can write down cos 105 as again 60 plus 45, right? Here again, you can see that we are having the two formulas, right? Sin A plus B and cos A plus B. We already know the formulas for both. I'm not going to write down the formulas again. You already know the formula, but you make sure that when you are solving any question in your exam or anywhere, you make sure you write down the formula on the other side, even if the formulas are getting repeated. So sin A plus B, we know the formula. It is sin A. Okay, 1 second. Sin A, that means sin 60, sin A cos B, so cos 45, plus cos A sin B, so cos 60, sin 45. Now here, it is cos A plus B, and we know that cos A plus B, the formula is cos A cos B minus sin A sin B. Now, all we need to do is, we need to just simply put the values, okay, that we already know. Sin 60, root 3 by 2. Cos 45, 1 upon root 2. Cos 60 half, sin 45, 1 upon root 2. The value of cos 60, 1 upon 2, cos 45, 1 upon root 2, minus sin 60, root 3 by 2, and sin 45 is 1 by root 2. Now, let us write down this. We can simplify this further. So, the very first expression is root 3 times 1, that is root 3 upon 2 root 2, plus this will become 1 into 1 is 1, 2 root 2. This will become plus 1 into 1 is 1, 2 into root 2 is 2 root 2, minus 3, root 3 into 1 is root 3, and then 2 root 2. We can notice here one thing, that this term and this term will get cancelled because they are plus minus and they are the same terms. So we are getting 1 upon 2 root 2 plus 1 upon 2 root 2. So we have to prove that this will be equal to only 1 upon root 2. So we have not received the RHS yet. So we can simplify that further by taking LCM. So if I take LCM, of course, I'm getting 2 root 2 and in the numerator 1 plus 1. Now what is 1 plus 1? 1 plus 1 is 2 upon 2 root 2. This 2 and 2 will get cancelled. So what exactly are we getting? We are getting 1 upon root 2. We are getting 1 upon So we are actually getting 1 upon root 2, and that is nothing but our RHS. And we wanted to prove LHS is equal to RHS. hence proved. All right, so now let's go to the last question of this video, because I really don't want to make this video very, very long, because I really want to watch the entire video. So let us go to our last question for today's video. So it is tan 13 pi over 12. Okay. So we can write down this as, we have to find out the value of this. Okay. So I can write down this as tan 13 pi by 12. I can write down this as pi plus pi by 12. Now, of course, if you solve this, you can see that it is, if you take the LCM, it is 12 pi plus pi upon 12, which is 13 pi by 12 only. That is given in the question. So I have just written the back step, 13 pi by 12, I have written in this form. Now you can ask that why exactly this form only and not any other form? Because I know that we have a formula of tan pi plus theta. That is why I just brought, that 13 pi over 12 in this form, in the form of pi plus some angle. So we know the formula of tan pi plus theta, it is tan theta. So using this formula, it will become tan pi by 12 only, right? And now this tan pi by 12, of course, we don't know the value of this. So what we can do here is, we can write down this as pi by 3 minus pi by 4. Now let's see why. If you simplify pi by 3 minus pi by 4, what is the LCM? 12. So 3 times 4 is 12, so 4 pi minus 4 times 3 is 12, so 3 pi. So 4 pi minus 3 pi is pi over 12. So you can see, again, I have done the backward thing, right? So because I'm getting this for pi by 12, so at the place of pi by 12, I have replaced it with this. Now, as soon as I get these two angles, see, we can write down the angles in two ways, either in the degree form or in the radian form. In the radian form, we just include the pi. In the degree form, we just have the angle like 60, 45, 35, 95, like that. So now, as soon as I get this angle, it is clearly in the form of tan A minus B, right? We know the formula of tan A minus B. It is tan A minus tan B upon 1 plus tan A tan B. So using this formula, this is tan pi by 3, that is tan 60, right? So what is the value of tan 60? That we already know, this root 3. Remember, why pi by 3 is 60? Because the value of pi is 180 only, right? So tan pi by 3 is actually tan 180 by 3. And 180 by 3 is 60, so tan 60. And we know the value of tan 60, that is root 3. Tan pi by 4, it is actually 45, because 180 divided by 4 is 45. And we know the value of tan 45, that is 1 minus 1 plus tan pi by 3, again root 3, and this is 1 only. So what is the answer we are getting? We are getting root 3 minus 1 upon root 3. I can write down first and then plus 1, right? Here, if you want, you can leave the answer at this place as well, where you can say that the answer of, this is root 3 minus 1 upon root 3 plus 1. But what I'll do here is, I will rationalize this. What is the meaning of rationalization? Whenever you see any irrational number, of course, root 3 is an irrational number. So root 3 plus 1 is also an irrational number only. So we rationalize it by multiplying by the same number in the numerator, by multiplying by the same number in the denominator with the sign changed. So root 3 plus 1, right? So this will become root 3 minus 1 and upon root 3 minus 1. Now in the numerator, we have root 3 minus 1 times root 3 minus 1, which is same as root 3 minus 1 whole square. And in the denominator, we are actually having a plus b into a minus b form. We know that a plus b into a minus b, the formula is a square minus b square, right? So using that formula, I'll just write down the formula here, that a minus b times a plus b, the formula is a square minus b square. So using this formula, it will become root 3 square minus 1 square, which is 1 only. Now in the denominator, we are having a minus b whole square form. This is a very basic and a very simple formula. A minus b whole square is a square plus b square minus 2ab. So using this formula, it will become root 3 square, that is 3, plus b square, that is 1 square 1, minus 2ab. So 2 times root 3 times 1, that is 2 root 3, upon root 3 square is 3 minus 1. Now 3 plus 1 is 4, 4 minus 2 root 3, and 3 minus 1 is 2. Now from the numerator, I can take 2 common. So what I'm getting? 2 times 2 is 4, and here root 3 only, and then upon 2. Now this 2 and 2 will get cancelled. So what is the final answer I'm getting? The final answer that I'm getting is 2 minus root 3, and this is the answer. So in today's video, this is it. Okay, for today's video. In the next video, of course, I'm going to cover some important questions as well for all the grades. Of course, I am covering today the 11th grade maths, but topic I can say. But yes, in the coming video, I'll be changing the grades as well. I'll be changing the topics as well. But yes, thank you so much for watching my videos and supporting my channel. Thank you so much for that. So I'll be meeting you super soon in the next video. Till then, thank you so much for watching. Bye guys.